So they're talking about ages of cats, and the traditional way of learning the age of a cat, or actually the age of a dog, they used to say that one human year was equivalent to 7 cat years. Okay, so that's the way many of you have maybe heard of. So they've asked you to fill that in for this model, and it's quite easy, isn't it? Because it's just the 7 times table: 7, 14, 21, 28, 35, 42, etc., etc., etc. And if we look at what's happening here, we know that we can see the pattern is just plus 7 each time. So it's really easy to get what it would be for n. Number of years, the formula would be 7n. But then they've got another one where they're saying, okay, there's actually a different formula called Model B, where they say that the first year the cat gets 15 years old, and the second year of its life it adds on 10 years, but after that it just adds 4 each year. So we get then 29, 33, 37, 41. So we can see that there is a pattern here, plus 4, but only when n is greater than 2. So what would the formula be? N is greater than 2. What we have to do is we have to ignore these two and imagine going backwards. Remember, to get the interval, we know that it's going to be 4n plus something. And to get what the plus something is, we take this back. Instead of going from level 3, we take it back to a fictitious level 2, which would be minus 4. Not from here, sorry. Here we've already got our plus 4. Take it back from year 2, a fictitious minus 4 would give us 21. That would take us back to our real year 1, if this formula. And then if we took it back to our real year 0, it would be 17. So our formula for this is 4n plus 17, because remember, it's whatever the interval is, but take it back to our year 0. So for when n is greater than 2, our formula would be 4n plus 17. And we can check that it works for any of them. You've got your calculators, it does actually work. So we sort of put these ones in brackets, because we know that that's going to be a steep curve there, but the rest of it, how could we represent that straight line using the formula for n plus 17? Okay, so then it says fill in the table, which we've done. You can get quite good points for that. Then draw the number of years on some coordinates here. Well, if we take 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. This is calendar years. This is real years. A cat can live to be about 20, 22. Not unusual, but not much longer than that. 20 years is usually about the max. And then human years then. Well, let's say 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And we have to just plot a few points then. Well, when we're at 2 years, we should be at 14 for Model B. And at 4 years, 28 for Model B. And at 6 years, 42. So whenever we've got a straight line, as we have in Model A, we only really need 3 points. 3 points means you could do 2 points, you could do one of them slightly wrong. If you've gone 3 points and the line goes perfectly through the 3 points, then you've drawn everything right. And we're expecting it to go through origin, it's born at 0, and through all 3 points. We have our model A. And mine isn't perfect because I haven't got lined paper like you have, but you get the gist of it anyway. So if we do Model A in black, I'm going to put the top, and then we do Model B then. Well, Model B is different, isn't it? Because in year 1, it's already gone 15 years. From 0 to year 1. And by year 2, it's at 25. So we get a very steep curve in the beginning. But then after that, we're just adding each year. So year 4, 33. year 6, 41. And again, we need about 3 points. And mine isn't going to be perfect, of course, like yours is. And then we can draw in, anyway, model B. So up to year 2, we get a steep curve. And then after year 2, we should get a straight line going off like this. Model B. It looks a bit steep, actually. Okay, so that was the question, be able to draw on a coordinate system. Whenever we're drawing on a coordinate system, remember to label our axis well. Make sure that our interval is correct. There's the same distance here. And we've labeled that this is the number of cat years. We've clearly marked which one of our lines is representing model A and which one of our lines is representing model B. Good to use different colour pens so it's extremely clear. And then it says, after approximately how long time will both of the cat's ages be the same? Well, we're looking for the point where the two lines cross. And we can see if we drop down a vertical, which of course we should do with a ruler or a set square, getting a perpendicular line at the point it crosses. Here we've come down at a 90-degree angle to the x-axis, and we can see that it's slightly less than 6 years. So that was question C. We can see from the graph the cats, the models give the same cat age at slightly less than 6 years. But it also says, and that can give you quite a lot of points, but it says exactly. And if we're going to do it exactly, it's not good enough to just read it off a graph. If we're going to do it exactly, we actually have to use these two expressions for x number of years or n number of years. So when these two models cross, 7n is going to equal 4n plus 17. Model A is going to equal and be identical to model B. We now have an equation with one unknown, n, and numbers. So now it's easy to solve. Subtract 3 from both sides. Subtract 4n, sorry. Minus 4n to both sides will give us 7n minus 4n equals 4n minus 4n, which will go to 0, plus 17. So we know that 3 lots of n equals 17. Therefore, n will equal 17 over 3, which is the same as 5 2/3 of a year. Now we have an exact answer that we've proved using our algebra skills. So when n equals 5 2/3, then the next question is, cats can be really old, and it's not unusual that they live to be 20. You didn't maybe know that, but the question tells you what you need to know from common sense in order to be able to continue. Which of the models is the most reasonable and motivate your answer? Well, if we were to put n equals 20 here, we would see that for model A, 7 times 20, 140. 140 years. What would we get here? We'd get 4 times 20, which is 80, plus 17, which is 97. So 97 is reasonable, but how many humans do you know running around at 140? And if it's not unusual for a cat to be 20, it's not too unusual either for a person to be 100. That's reasonable, but model A isn't reasonable. So you can do it using your algebra from the formula. Or you can do it by making your graph so long that it goes all the way to year 20. And you can actually read off the graph, where do we get for year 20? We're going up here. We can see that model A will cross at around 100 here. So we could say that, not model A, sorry, model B is reasonable, but model A is way off the graph. I'm probably going to go up. And in mine, I actually drew it all the way up to around 140. I had a long axis there. So I'd expect you could either say something like, if I extend the graphs, graph A can be extended easily. It's both linear and proportional. Whereas graph B becomes linear from year 3. Extend both graphs approximately until x is 20 and record the value of y. Model A is off the graph and approximately equivalent to 140, 150 human years. This is unreasonable. It's not uncommon. If it's not uncommon for a cat to be 20, no humans have ever lived to be 140, 150 that we know of. So therefore model A is unreasonable. Model B at 20 calendar years, that gives an equivalent age in human years of around 90. This is reasonable. Many adults in the Western world live to be 90 years. And then you could have proven it using your algebra skills there as well. And if your solution looks like this, neat, well explained, you've shown that you can work out the formula of an algebraic sequence, you've done a really nice plot of the graph, you've made sure your axes are clear, you've made sure that your lines are clear, and you made sure you answer all of the questions as well as you can. That took us, a bit less than 15 minutes to get all the possible points for that. Okay? How did you guys